Okay, today we are going to start a new topic, that is what that we studied in previous class, that average velocity, so average speed. So we have to do a problem related to with this average speed. So what is the equation of average speed? So average speed is calculated by, yes, average speed is equal to what? Total distance covered by total time. Total distance covered by total time. So average speed is equal to total distance covered by total time. This is the, in this way we can find what the average speed. So let us check with an examples. Okay, suppose if an object moves, okay, suppose if an object moves 18 meter in 4 seconds. 18 meter in 4 seconds. 18 meter in 4 seconds and another 18 meter in 2 seconds. Suppose, okay, this is an example, this is a problem to find average speed of an object. So what is our problem? So if an object travels 18 meter in 4 seconds and another 18 meter in 2 seconds, so what will be the average speed of an object? Okay, suppose we can represent this problem with a diagram. Okay, suppose the object travels 18 meter, this 18 meter, okay, 18 meter in 4 seconds and another 18 meter in 2 seconds. Another 18 meter in 2 seconds. So what will be the average speed of an object? So how can we find average speed? Average speed can be calculated by total distance by total time. So what is the total distance here? So average speed, how can you find total distance by total time? So what is the total distance here? Total distance is 18 meter plus 18 meter, that is 36 meter. Total distance is here 18 meter plus 18 meter. So total distance is what? 36 meter. And next by total time. What is total time here? 4 seconds plus 2 seconds. 4 seconds plus 2 seconds. So what will be total time? 6 seconds. Total time is 6 seconds. So what we will get? 36 by 6. What? 6. Okay. How many sixes will be in 36? What? How many? 6. And unit is what? What is the unit of speed? What is the unit of speed? Meter per second, or ms inverse 1, or ms raised to 1. So 6 s raised to 1 minus 1. 6 ms raised to minus 1. This is the speed of an object. Speed of the object. Average speed of an object. Average speed of an object. Okay. Sometimes, okay, here the object might not travel in 6 meter per second all time. Okay, object might not travel in 6 meter per second all time. Object might travel faster or slower than this. Okay, object might not travel this 6 meter per second indicate that object might not travel in the speed 6 meter per second all time. Okay, sometimes the object may travel faster, sometimes object may travel slower than this. Okay, this indicate that object will not travel. Object will not travel in the speed 6 meter per second. Object sometimes will travel faster than this, sometimes slower than this, sometimes maybe in this speed 6 meter per second. Understand? Object may not travel or will not travel in this speed all time, in all time. Sometimes object may travel faster than speed, sometimes object may travel slower than speed, sometimes may travel in this speed. So this is average speed. The object will, this average speed is 6 meter per second. That indicates that object will not travel in 6 meter per second in all time. Will not travel. Sometimes it may travel what? Faster than this. Sometimes it may travel that slower than this. Sometimes it may travel what? In 6 meter per second. So this is average speed. So average speed is calculated by total distance by total time. Okay, total distance is here 18 plus 18, 36. Total time is what? 4 plus 2, that is 6 meter per second. So in this way, average speed that we have to find. So in this way we are finding the average speed. Next, we are going to study what velocity. Another term is what? Velocity. So one thing before that, so average speed or this average speed can be represented by letter. Speed is total distance by total time. Total distance can be represented by d. Okay, distance can be represented by d, and time we can represent by time t. Okay, time we can represent by t. So average speed, that is v average. Speed is represented by letter v or s. Okay, yes. Speed is represented by capital letter S. S average is equal to d by t. Okay. Speed is represented by capital letter S. Average is equal to total distance is represented by d and total time is represented by t. So average speed is equal to what? D by t. So average distance can be represented by, or equation can be represented. Equation to find average speed can be represented by, average speed is represented by S average, our total distance is represented by d and total time is represented by what? T. So this is the equation. Okay, representation of equation, symbols of equation. Next is what? Velocity. Okay, next is what? Velocity. So velocity is what? So what is speed? Speed is the distance travelled by an object in unit time. What is speed? Speed is the distance. Speed is the distance travelled by an object. Distance travelled by an object in 1 second. In 1 second. This is speed. Speed is the distance travelled by an object in 1 second. So what is velocity? Velocity is the displacement. Okay, we studied about the difference between distance and displacement. Displacement travelled by an object in 1 second. 1 second. Okay, so speed is the distance travelled by an object in 1 second. velocity is the displacement traveled by an object in 1 second. Okay, this is a difference. Okay, so this is the velocity. Speed is what? A distance traveled by an object, but velocity is the displacement traveled by an object in 1 second. So this is the velocity. So next is what? Here, how can we find that velocity? Okay, how can we measure the velocity of an object? How did we measure the velocity of speed of an object? How did we measure the speed of an object? Okay, speed of an object S is equal to, S is represented by letter, speed is represented by letter S. Yes, so capital letter S is equal to d by t. So distance by time. In this way we are by that the equation of speed is what? Speed is equal to distance by time. Okay, so what is velocity? Velocity is represented, speed is represented by letter S, speed is represented by letter S, velocity is represented by letter V. Understand? Okay, here distance is represented by letter D, time is represented by letter T. So velocity is equation of velocity is what? Equation of speed is what? Distance by time. So equation of velocity is what? Displacement by time. Displacement by time. Okay, here velocity is represented by letter V and displacement we can represent by small letter S. Small letter S. Time we can represent what? Small letter T. So this is the velocity. In this way we can find the velocity of an object, displacement by time. Speed, how can we represent? Speed is equal to distance by time, velocity is equal to displacement by time. So what is average speed? Average speed is equal to total distance by total time. Average speed we have to what? Yes, we can write what? What is average speed? Average speed. What is the equation of average speed? Total distance. Okay, total distance by total time. Total time. Understand? Speed is what? Distance by time, but average speed is what? Total distance by total time. So let us come to the velocity. So speed is distance by time, velocity is what? Displacement by time. Displacement by time. So here distance is what? Distance has only that we studied what in previous class, that difference between distance and displacement. Okay, so in that class we studied that distance has only magnitude. Distance has only magnitude but no direction. Okay, and displacement has both magnitude and direction. Magnitude and direction. So distance has only magnitude, so speed has only magnitude. Distance has no direction, so speed has no direction. Understand? Speed has no direction. So displacement is what? Displacement has both magnitude and direction. So velocity will also have what? Both magnitude and direction. Understand? Distance has only magnitude but no direction. So speed has only magnitude but no direction. Displacement is what? Displacement has both magnitude and direction. So velocity will also have what? Both magnitude and direction. Understand? Okay. Suppose we can we can understand with an examples. Okay. So suppose an object is moved. So this is a point A. Object is moved from A to B. Suppose an object is moved from A to B. This is A and this is B. Okay, and the object travel from A to B. The distance from A to B is what? 50 meter. Okay, 50 meter in 2 seconds. Time is 2 seconds. So what is speed here? Speed is equal to what? Distance by time. What is distance? 50 meter, and what is time? 2 seconds. So what is speed? 25 meter per second. 25 meter per second. Suppose this is what? This is south direction, and this is north direction. Okay, this is south direction, and this is north. Okay, so here this is the speed. Here we are only representing the magnitude. Magnitude is what? 25. So my weight is 60 kilogram. So what is magnitude? 60. This is magnitude. Okay. Magnification, magnitude, that is quantity. Okay, quantity. Here 25 is the magnitude. Okay, we are not that what we have to, we are not to represent direction. So what is velocity here? So here 25 is the magnitude. In the case of speed, we are only representing, we have to only represent what? Magnitude. So what is velocity here? Velocity is displacement by time. What is the displacement? What is the definition of displacement? Displacement is the shortest length between initial and final point. Shortest length between initial and final point. So what is shortest length between initial and final point? 50 meter. So displacement is what? 50 meter. Okay, 50 meter. And what is time? 2 seconds. Time is 2 seconds. So what will be the value? What will the value? 25 meter per second. Okay. And also we have to represent velocity has both magnitude and direction. Speed has only magnitude, but velocity has both magnitude and direction. Okay. Here we have to represent. We represent here only magnitude. We have to represent direction also. Okay. Suppose the object is moving from south to north. Okay, in north direction the object is moving. So we have to represent here direction also, north. Okay, velocity on object is 25 meter north. 25 meter per second. 25 is the magnitude, north is the direction. So in the case of speed, we have to only represent magnitude. So but in the case of velocity, we have to represent both magnitude and direction. In which direction object is moving? Object is moving north direction. Okay, so in the case of speed, we are not to represent direction. We have to only represent what? Magnitude. But in the case of velocity, we have to represent both magnitude and direction. Okay, what is magnitude here? 25. Okay, magnitude is also digital number. Okay, at 25. Okay, and what? Direction is what? North. Because the object is moving from south to north. So what will be the direction? Direction will be north. Okay, so this is the difference between speed and velocity. And next is what? How can we find? Yes. So next is what? We can come to the velocity. So we studied what? Velocity has both direction, both magnitude and direction. Velocity has both magnitude and direction. Speed has only magnitude but no direction. Okay. So velocity can be changed. Velocity can be changed if there is a change in magnitude or direction or both. Okay, velocity can be changed if magnitude is changed, okay, or direction is changed, or both. Understand? Velocity is changed if magnitude is changed, or otherwise direction is changed, or both. Okay, suppose, listen here. All of you listen here. Yes, that we can understand this word. Okay, what velocity can be changed. Okay, you have to understand very carefully what velocity can be changed. Velocity can be changed if there is a change, if there is a change in magnitude, if there is a change in magnitude, or if there is a change in magnitude or direction, or magnitude comma direction, or both. If magnitude is changed, velocity can be changed. If direction is changed, velocity can be changed. If both direction and magnitude are changed, then velocity can be changed. That we can study with an examples. Okay, with an examples. With the help of an example only we can understand. So this property of velocity can be understood. Velocity can be changed if there is a change in magnitude, if there is a change in direction, if there is a change in both means magnitude and direction. Listen here. Suppose an object, okay, object starts from A to B, okay. Sorry, A, B, C, D, B, C, D. Okay, object, yes, object is moving. This is the points A, B, C, D is the place. Okay, so object start is moving from A to D. Object starts from A to D, or object travels from A to D. Object is travels, or object is traveling from A to D. Okay, this A is the starting point or reference point. On this point, the velocity of an object is 0 meter per second. What? 0 meter per second. On reaching B, its velocity is 5 meter per second. Okay, 5 meter per second. Velocity is increased by 5. Velocity is increased by 5. On reaching C, its velocity is 7 meter per second. Velocity is 7 meter per second. On reaching D, its velocity is suppose 8 meter per second. So here velocity is changed. Velocity is what? Magnitude is changed. Magnitude is what? Value. Value is changed. 0, 5, 8. These are the magnitude. 0, 5. Okay. 0. Here is the magnitude. 5 is the magnitude. 7 is the magnitude. 8 is the magnitude. Here magnitude is changed. Understand? Magnitude is changed. But direction is not changed. Because it is a straight line. It is a path is a straight line, so direction will not change. If an object moves in a straight line, direction will not change. So direction is not changed. Okay, suppose this is south and this is north. Okay, so always it is travels from in a direction north. Okay, in all points direction is what? To north or north. Okay, in all point is direction is toward north. So direction is not changing, but magnitude is changing. 0 and another point 5, another point 7, another point 8. So magnitude 0, 5, 7, 8. These are the magnitude. Magnitude is changing, but direction is always toward north. So in this case, velocity will be changed. Okay, here velocity will be changed. So velocity is changing. And suppose another case, this is the first case. Here velocity can be, if magnitude is changing, here magnitude is changing, so velocity changing. Velocity has both magnitude and direction. Magnitude and direction. Here magnitude is changing, so velocity can be changed. Here magnitude, m represents what? Magnitude, so velocity is changing. Okay, next case, what? Suppose So point A, so point B, C, D. Okay. Here objects at O, object speed is what? Object is moving in a circle. Okay. Object speed was 2 meter per second. And B is what? 2 meter per second. And C what is speed? 2 meter per second. And D what is speed? 2 meter per second. Here direction is magnitude is not changing at all point. In all points magnitude is what? 2 2 2 2 2. So magnitude is not changing. Okay, magnitude in all points. What is the magnitude? What is the value? 2 meter per second. 2 2 2. So magnitude is what? Not changing. But direction is changing. Okay, at A there is what is direction? Up. Okay. At A, at B, direction is changing. At C, what is direction is? Suppose the object is moving in this direction. Okay, in this direction. So all point direction will be changed. And at B, direction will be like that. At C, direction will be down. At D, direction will be like that. Understand? So direction, all point direction will be changed, but magnitude is changing. So here direction is changing, then velocity can be changed. Magnitude is not changing. Magnitude is not changing. Here magnitude is not changing, but direction is changing. So velocity will be changed. Okay. The next we can study another topic next class.